Okay, welcome. I'm Romario Vegas Francisco Marsal with the number ID student number 1301225 So here in the first questions, it's we need to find the integral of square root of 1 plus square root of x over x dx, and we try to using the method of rationalizing substitutions. So here we try to simplify, we try to consider that the square root of x is equal to u. So x, we try to replace the square root to the right side of the equal sign. It should be u square. So x equal to u square. So here x equal to u square, or the derivative of x or dx is equal to 2 du, 2u du. So here we already have the value of u, x, as well as the dx. We try to simplify, we try to substitute it. So the integral of square root of 1 plus u over u square times dx changed to 2u du. So here we have integral of 2 square root of 1 plus u over u du. And this is the first substitutions, because this is pretty complex. We need a double substitutions of rationalizing. So let's start with the second substitutions. We consider p, okay? P equals to square root of 1 plus u, which is p square, because the square root is turned to the left side of the equal sign. It's p square equal to 1 plus u. So u is equal to p square minus 1, right? So minus 1, it's moved to the left of the equal sign. So here we have the derivative of u, it's equal to 2p dp. So okay, so now again we put the integral of 2p over p square minus 1 times 2p dp. Okay, so we have the integral of 4p square over p square minus 1 dp. So here it's a pretty tricky thing. So we try to remove this. So to remove 4p square, we need to subtract it with 3p square, right? So in order to balance it, we also need to plus 3p square as well. If we try to make it 1 from the numerator and denominator, we also need to put it plus 1. So that's why it can be 4p square minus 3p square is equal to 1, right? So p square 1, this is 1. So 1 dp. It came from this. This is the extra calculations that I did. For example, like here we have 4p square minus 3p square minus 1 plus 3p square plus 1 over p2 minus 1. So here p2 minus 1, we just erase it, plus 3p square plus 1 p square minus 1. So here we have only 1 dp plus 3p square plus 1 over p square minus 1, the integral of dp. So again, we come back to this stage. So here this is where this is come from. It's come from the method of partial fractions decomposition, which is we try to find this. We simplify this, okay? We simplify this p square minus 1 to a over p plus 1 plus b over pi p minus 1. So it's considered to be a and b, and 3p square plus 1 over p plus 1 p minus 1 times p minus 1, and a times p minus 1 plus b times p plus 1 over p plus 1 times p minus 1. So it's x. In order to we erase the value of a, we put x equal to 1, therefore a erase, and b is equal to 2. And in order to erase the value of b, we need to put x equal to -1, so that's why a is equal to -2. b is 0, a is equal to -2, because 4 over -2 is equal to -2. After we got this and we just simplify this, the integral of 3. Every number that over something, it's a ln, right? The integral is a ln, so that's why p plus 3p plus 2 ln, the absolute value of p minus 1, minus 2 ln the absolute value of p plus 1 plus c, because it was indefinite integral. It's equal to 4p plus 2 natural log of absolute value p minus 1 minus 2 natural log of absolute value p plus 1 plus c. So here the final integral of square root of 1 plus square root of x over x dx equal to 4 square root of 1 plus u plus 2 ln square root of plus 2 ln the absolute value square root of 1 plus u minus 1 minus 2 ln the absolute value of square root 1 plus u plus 1 plus c. So the final answer was 4 square root of 1 plus square root of x. We just try to replace it with the original values, okay? So 4 square root of 1 plus square root of x plus 2 ln times the absolute value square root of 1 plus square root of x minus 1 minus 2 ln the absolute value of square root of 1 plus square root of x plus 1 plus c. So done. Let's move to the next question. So let's move to the second question, which is here. I'm gonna try to explain the number 2.2 using trigonometric substitution method, which is here. We're going to find the integral of dx over square root of x squared plus 2x plus 5. So here we need to simplify first the denominator, which is x squared plus 1 square is equal to x squared plus 2x plus 1. So that's why I only need to plus 4. Therefore 4 plus 1 is equal to 5. So after we simplify this, we move to the expression in trigonometric substitution method. The expression told us that in the numerator we have like x squared plus a squared. So x squared it should be here and a squared it should be here. So because of that, this we just substitute it by x equal to a tangen theta. So a here it's 2. Why is 2? It's because like it's 4, right? 2 square is equal to 4. So that's why the a is equal to 2. So after we have the substitution of this expression, we also can find out the derivative of x, which is derivative of x equal to 2 second square theta d theta. So after that, we're going to drawing the the triangle of trigonometry. Here we have the first and the second image. So next, we already have the expression for the numerator, right? The dx. Now we are trying to find the denominator one. The square root of x squared plus 2x plus 5. So here square root of 2 of x squared is equal to 2 squared plus x plus 1 squared equal to 2 second theta. Why it's equal to 2 second theta? Because second theta is equal to square root of x plus 1 squared plus 2 squared over 2. So it can be tangen theta equal to x plus 1 over 2. So x plus 1 it's equal to 2 tangen theta. So x plus 1 u is equal to x plus 1. So here u also it could be u as well. It could be u as well. U equal to a tangent theta, so 2 tangent theta for u as well. But we can move it to u, du, it's u, and it's du, so it's also u. So okay, done. So after this, we got the two expressions of trigonometric substitution for numerator as well as the denominator. So here, the integral of 2 secant square theta d theta over 2 secant theta is equal to integral of secant theta d theta. So we know that the integral of secant theta d theta, it should be ln secant theta plus tangent theta. We not forget to put c constanta because it was indefinite integral. So the last answer should be ln the absolute value of x plus 1 plus square root of x squared plus 2x plus 5 plus constanta or c. So this is the second one. Let's move to the final question. Okay, let's move to the final questions. Here we are going to find the area of the integral with the limit start from 1 to until 2, 15 over x squared plus 7x plus 12. So firstly, we try to simplify the denominator, x squared plus 7x plus 12. We can replace it by x plus 3 times x plus 4, right? Because x times x squared, 3x plus 4x is 7x, as well as 3 times 4 is 12. So after that, we try to make the denominator same, which is we try to times the denominator. And here, with using the partial fractions method, we try to separate each denominator. So here we have the first denominator, it's a, and the second is b, as well as 15 over this denominator is we try to put it again. So after that, we try to multiply it, right? So we try to times it, so it remains the same, equal a times x plus 4 plus b times x plus 3, right? So the denominator also times to each other, so x plus 3 times x plus 4. So here we try to forget the integral first. The integral we put here, so just ignore it first. In order to, so here the first thing I'm trying to eliminate b. So by eliminate the b, I need to put x is equal to minus 3, right? Because minus 3 plus 3 is equal 0. Therefore, we have 15 equals to a times minus 3 plus 4 plus b times minus 3 plus 3. So here, when minus 3 plus 3, b it's removed. So remains 15 equals to a minus 3 plus 4 is 1. A times 1 is remains a. So a is equal to 15. Now we already got the value of a. So next we try to find out the value of b. So here I'm trying to remove the value of a, which is I'm trying to plus minus 4, right? Therefore minus 4 plus 4 is equal to 0. So therefore we have 15 is equal to a times minus 4 plus 4 is equal to 0, right? So plus b times 2 minus 4 plus 3 is equal to minus 1. So here a is eliminated. We are only minus b is remains. So b is equals to minus 15 because the minus try to change from the equal sign. So it should be negative. So that's why b is equal to minus 15. So now we already got the value of a and as well the value of b. So we try to put again the integral. So the integral of the value of a is 15 over x plus 3 du plus integral with the limit start from 1 till 2 of minus 15, which is its b, right? We just replace it using this formula and just replace it and just put the integral back again, x plus 4. So after that, we can make the 15 numbers, put it outside on the integral, right? We can put it like, so that's why the 15 is put outside. It's also minus 15 also put in the outside as well. So therefore, we just try to simplify it using this integral. As we know that every numbers that over something, it's length, right? Natural log, right? That's why the integral of 1 over x plus 3 is equal to natural log of absolute value of x plus 3, as well as this minus 15. The integral of this is equal to minus 15 natural log of absolute value of 4 of x plus 4. So in the limit start from 1 until 2. After we got this expression, we just substitute 1 and 2 into the x value. So that's why we have 15 a natural log of absolute value 2 plus 3 minus 15 natural log of 2 plus 4 minus 15 natural log of 1 plus 3 minus 15 natural log of 1 plus 4. So after that we get this 15 natural log of 15 minus 15 natural log of absolute value of 6 and minus 15 natural log of absolute value of 4 minus 15 natural log of absolute value of 5. It's absolute value of 5, right? It's not 15. Sorry, it's my mistakes. Absolute value of 5. So we try to put the 15 outside. Therefore, we have 15 times natural log of 5 minus natural log of 6 minus natural log of 4 plus natural log of 5. So in natural log, in logarithm, the sign value plus, it should be multiplication, and the subtraction sign or sign, it should be a division operation. So that's why natural log of 5 plus natural log of 5, it's like 5 square, so it should be 25. So 15 times natural log of 25 over, so 6 times 4, it's equal to 24, right? Because it's minus, so it should be division, so 25 over 24. So we have a 15 natural log of 25 over 24. It's equals to 15 natural log of 25 over 24, or because it's a definite integral, so we have like the value approximately of 6, 1, 2 and 0.6123. Okay, this was the final answer. Thank you.